Hello students, in today's class we can start this chapter 3D. So in this 3D we have three dimension, x-axis, y-axis and z-axis. So all are mutually perpendicular to each other. So which means if I take this as x-axis and this is y-axis and this is z-axis. So now here we have 90 degree. X and y, the angle between x and y is 90, the angle between y and z is also 90, and the angle between x and z, this angle is also 90. So all are mutually perpendicular to each other. So if I take any point on x-axis, the coordinate of y and z will be 0 here, so which means it will be of this form x comma 0 comma 0. And if I take any point on y-axis, the coordinate of y, x and z will be 0 here, so 0 comma y comma 0 will be there. And if I take any point on z-axis, so it will be 0 comma 0 comma z will be there. The coordinate of x and y, here it will be 0. Now the next thing you have to know here is distance formula. So we know how to find the distance between 2 points. This we have learned in 11th standard as well. So just root of x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. So next we will see directional cosines of a line. So you know very well what is directional cosines of a vector. So now we will see what is directional cosines of a line. So now what I am taking here is, in line I am taking one point P. So the coordinate of P is, let's say it is x comma y comma z, which means the vector OP vector will be equal to xi cap plus yj cap plus zk cap. The angle which this vector makes with the positive of OX, which means this is the positive of OX and positive of y axis and positive of z axis and OZ, are called directional angles, and their cosines are called directional cosines. So which means the angle, direction angles we have here is alpha, beta, gamma are the directional angles. Cosine of this, cosine means cos, cos alpha, cos beta and cos gamma. So these are the directional cosines we have. So hence if alpha, beta, gamma are the directional angles, then the directional cosines are cos alpha equal to x by r and cos beta will be equal to y by r. So this will come in vectors also, same thing, cos gamma equal to z by r. Why x by r means, if I draw one line like this, here it will be 90 degree perpendicular, this distance will be x and this is the alpha here, and opposite to this 90 degree hypotenuse will be there. Hypotenuse is nothing but the magnitude of OP vector. So cos alpha is adjacent by hypotenuse, which means x by OP vector. So r is nothing but OP vector here. So x by r, similarly cos beta will be equal to y by r and cos gamma will be equal to z by r. Cos alpha, cos beta, cos gamma are denoted by the letter L, M and N respectively. Now if we see here, this Li cap plus Mj cap plus Nk cap, this will be unit vector, which means what we can say here is the component of unit vector. Note, components of unit vector, component of unit vector are the directional cosines of the vector, or the directional cosines of the vector. So components of unit vector, suppose if we have any unit vector, let's say a cap denotes it is a unit vector, and if I have ai cap plus bj cap plus ck cap like this, the components whatever we have here, so this will be L and this will be M and this will be N. So the components of unit vector will be the directional cosines of the vector. Here in directional cosines L, M and N we have, so this L square plus M square plus N square will be equal to 1 always. So which means cos square alpha plus cos square beta plus cos square gamma will be equal to 1. From here we can see one relation also. This cos square alpha can be written as 1 minus sin square alpha. Since sin square theta plus cos square theta equal to 1, cos square theta will be equal to 1 minus sin square theta. So this can be written as plus 1 minus sin square beta, and this can be written as plus 1 minus sin square gamma. It will be equal to 1 here. So from this 1 plus 1 plus 1, so it is 3. So if I bring this 1 here, so 3 minus 1. So sin square alpha, it is going to the right hand side. So it will be sin square alpha plus sin square beta plus sin square gamma will be equal to 3 minus 1 we have. So which means from here we got another relation. So which is sin square alpha plus sin square beta plus sin square gamma will be equal to 3 minus 1, which is 2. So we have two relations. Cos square alpha plus cos square beta plus cos square gamma will be equal to 1, and sin square alpha plus sin square beta plus sin square gamma, it will be equal to 2. See, the components of unit vector is the directional cosine. Suppose if I give some vector, let's say a vector, we have to find directional cosines. So a vector, if I give 3i cap plus 4j cap plus 5k cap, now we have to find the directional cosines. So if I have to find the directional cosines, first what I can do here is I can find the unit vector. So we know how to find the unit vector. This a cap will be equal to a vector divided by magnitude of this a vector. So which means now it will be a unit vector. This a cap will be a unit vector, which means the component of this a cap are the directional cosines we have. So here we have to find the magnitude of a vector, so which is root of 3 square plus 4 square plus 5 square. So it will be equal to 9 plus 16 plus 25. So it will be equal to 50. So it will be 3 by root 50. 4 by root 50 and 5 by root 50. So this is the directional cosines we have. So like this only we have to find the directional cosines. The components of unit vector are the directional cosines we have. Next, see here, note if a line makes alpha, beta, gamma, if line makes alpha, beta, gamma with x, y and z axis respectively, this is for line, okay, respectively, then pi minus alpha, pi minus beta, pi minus gamma is another set of angles. We have another set of angles that the line makes with principal axis. Hence L, M and N are directional cosines of line. We denote like this. Then minus L, minus M and minus N are also directional cosines of the same line. Suppose if we have on 3D like this is one line, so it makes some alpha from this line and this angle from this also in this direction. So total one complete straight line we have pi, which is 180 degree. So this angle will be pi minus alpha. So which means it makes alpha as well as pi minus alpha. So from here what we have here is cos of this pi minus alpha. So we have taken cos alpha equal to L and cos beta equal to M, cos gamma equal to n. So which means it makes some angle pi minus alpha also. So which means cosine of this pi minus alpha is also the directional cosines. So pi minus beta, and here pi minus gamma. So from here pi minus alpha will be equal to minus cos alpha, because cos pi minus theta, since it is in the second quadrant. In second quadrant the sign of cos is negative. So here cos pi minus beta, it will be minus cos beta, and here cos of pi minus gamma will be equal to minus cos gamma. So here this is nothing but minus L, and this is minus m, and this is minus n. So which means whenever if they are asking the directional cosines for a line, then L, m and n are directional cosines, as well as the negative of that minus L, minus m and minus n is also the directional cosines, because it makes two angles, one is alpha and the another one is pi minus alpha. So next we will see what is directional ratios of a line. Directional ratios of a line. See, here directional ratios is nothing but three numbers. This is one number, three numbers which are proportional to directional cosines, which are proportional to directional cosines of a line, or called directional ratios of a line, or called directional ratios of a line. Which means if I take the directional cosines of directional ratios of a line as, let's say, A, B, C, and directional cosines we have denoted as L, M and N. If they are proportional, which means L by A equal to M by B will be equal to N by C. So this we will have. So we know that L square plus N square plus N square is equal to 1. So this is same ratio we will have proportional. So I will take this as some equal to K. This ratio I will take as K. So from here L by A will be equal to K, which means from here I got L equal to AK, M equal to BK, because M by B equal to K, M equal to BK, and N by C is equal to K, which means N equal to CK. So from here we got one relation, we have one relation, L square plus M square plus N square is equal to 1, which means from here I can just substitute this A square K square plus A square K square plus B square K square plus C square K square is equal to 1. So from here what I can do here is I can take K square common. I will get A square plus B square plus C square equal to 1. So K square will be equal to 1 divided by A square plus B square plus C square. From here I got the value of K as plus or minus. Whenever if I take square root on both sides, plus or minus will come. So root of A square plus B square plus C square. So this is the value of K. Now L will be equal to AK. L will be equal to AK, which means L will be equal to, in K we have plus or minus, so plus or minus A divided by root of A square plus B square plus C square, and M is what? BK, which means M will be equal to plus or minus B divided by root of A square plus B square plus C square, and N will be equal to CK, which means N is plus or minus C divided by root of A square plus B square plus C square. Next, directional ratios of a line joining point A and B, joining points A and B. So A coordinate I will take as x1, y1, z1, 3D, and this one I will take x2, y2, z2. So the directional ratios for this is either it will be x2 minus x1, y2 minus y1, z2 minus z1, or it will be x1 minus x2, y1 minus y2, z1 minus z2. Suppose AB vector, if I have AB vector and A coordinate is this one, x1 comma y1 comma z1 and x2 comma y2 comma z2. So which means the initial point is A and the terminal point is B. So this will be the directional ratio for this AB vector. Suppose if I have BA vector in this direction, which means the directional ratios of this BA vector will be this. Since in line we don't have any direction, they have not mentioned it starts from A and ends at B. So either we can take AB vector or we can take BA vector. So here x2 minus x1, this pair will come, or this pair will come. I cannot write like this x2 minus x1, y1 minus y2. I cannot interchange. If I am writing x2 minus x1, here y2 minus y1 should be there. So these are the directional ratios of a line. So now we will see angle between two lines. So we have two lines, line 1 and line 2. Suppose directional cosines are given. Directional cosines are given. This we are finding angle between two lines. Angle between two lines. So two lines we have to find the angle between them like this angle. So now if directional cosines are given, which means L1, M1, N1, I will take the directional cosines of line 1, and L2, M2, N2, I will take the directional cosines for line 2. Now how to find the angle between them? So cos theta, this theta I will take as acute angle. Acute angle means cos of acute angle will be positive. Another angle, it will be pi minus theta, so this will be the negative of this. So cos of pi minus theta is minus cos theta. So the answer will be negative. So here it will be modulus of L1 into L2 plus M1 into M2 plus N1 into N2 will be there. If two directional cosines are given, this formula we have to use. And if directional ratios are given, directional ratios of line 1 and line 2. So line 1 I will take ABC, A1, B1, C1, and for line 2 I will take A2, B2, C2. So now if we have to find the directional ratios of two lines, directional ratios of two lines is given, we have to find the angle between two lines. So it will be modulus of A1, A2 plus B1, B2 plus C1, C2. So the whole divided by root of A1 square plus B1 square plus C1 square into root of A2 square plus B2 square plus C2 square. See here how we are getting this in same formula we can use here also, and here L1 square plus M1 square plus N1 square is 1, so only we have not written 1 in the denominator, and here also L2 square plus M2 square plus N2 square again 1, because A dot B, if I take dot product, it will be magnitude of A vector into magnitude of B vector into cos theta, and the cos theta will be equal to A dot B dot product divided by magnitude of A vector into magnitude of B vector. So if directional cosines are given, it is like this, the vector is like this, L1 I cap plus M1 j cap plus N1 k cap. So which means here L2 I cap plus M2 j cap plus N2 k cap. So what we have to do here is, for the angle we have to take the dot product. So dot product means L1 into L2 plus M1 into M2 plus N1 into N2 divided by magnitude of this Li cap. So it is one unit vector, which means the magnitude of that will be 1. So here 1 into 1 will be there. So which is magnitude of modulus of L1 L2 plus M1 N2 plus N1 into M2. Now if directional ratios are given, just we are using the formula A1 A2 dot product, because this vector is A1 I cap plus B1 j cap plus C1 k cap, and this vector is A2 I cap plus B2 j cap plus C2 k cap. Now just we have to multiply A1 A2 plus B1 B2 plus C1 C2. So this will be in the numerator divided by magnitude of this first vector, which is, I will take this as A vector and this as B vector. So magnitude of this is root of a1 square plus b1 square plus c1 square, and the magnitude of this vector a2 I cap plus b2 j cap plus c2 k cap is root of a2 square plus b2 square plus c2 square. So next, directional cosines of axis. So now if they are asking directional cosines of x-axis, which means the angle makes from the positive direction of x-axis to the line is 90 degree. So x-axis means this is that line, this is the x-axis, and the angle which makes from the positive direction of x-axis is 0 degree since it is on the x-axis itself. And here for y-axis it is mutually perpendicular, which means here 90 degree, and for z-axis again it is 90 degree. So these are the angles, this is alpha, this is beta, and this is gamma. So the next thing here is directional cosines of y-axis. So on y-axis, if some line is there like this, y-axis, so from x-axis it makes an angle 90 degree. From y-axis itself it makes an angle 0 degree. From z-axis it makes an angle some again 90 degree. Now the next thing, directional cosines of z-axis. So if I have directional cosines of z-axis, so this is that line, and from x-axis it makes an angle 90 degree. From y-axis also it makes an angle 90 degree. So from z-axis 0, so 90 comma 90 comma 0. Now all these are the angles. Now if we have to find the directional cosines for this, it will be cos of alpha, so cos 0, so cos 0 will be 1, so 1 comma 0 comma 0, and for this it will be 0 comma 1 comma 0, and for this it will be 0 comma 0 comma 1. Okay, so this is the directional cosines of axis. So what if it makes equal angles with x-axis, y-axis and z-axis, which means alpha is equal to beta is equal to gamma. So which means cos square alpha plus cos square beta, this we know, this relation we know, because L square plus M square plus N square is 1. So cos square gamma, it will be equal to 1. So here also I can substitute alpha itself, and here also I can substitute alpha. So cos square alpha plus cos square alpha plus cos square alpha, it will be 3 cos square alpha equal to 1. So which means from here I got cos square alpha equal to 1 by 3. Cos alpha will be equal to plus or minus 1 by root 3. So if it makes equal angles with the positive direction of x-axis, y-axis and z-axis, then it will be 1 by root 3 I cap plus 1 by root 3 j cap plus 1 by root 3 k cap. So we can have this vector, as well as the negative of this also we can have. So next we will see equation of line in 3D. Equation of line. Equation of line. We know how to find the equation of line in 2D. So here I will write for 2D and here I will write for 3D. So now if we have one line and one point on this line x1 comma y1 and slope if it is given, so this we call point slope form. Point slope form. So this is from 11th standard, point slope form. So point slope form is nothing but one point on the line will be given, on the line will be given, and slope of that line will be given, slope of the line will be given. If these two things are given, then easily we can write the equation of line. I can take one point x comma y. This x comma y is a moving point. It can be anywhere. So this is the fixed point. And now what I can do here is, we know how to find the slope if two points are given. So which means y minus y1 by here x minus x1. So now if I just multiply here, so y minus y1 equal to m times x minus x1. So this will be the equation of the line if one point and the slope of that line if it is given. Here in 3D also it is in the same way. So here also one point will be given, one point on the line will be given. And instead of slope, here parallel vector will be given. Instead of slope in 3D, in 2D, here parallel vector will be given. Parallel vector to the line. Parallel vector to the line will be given. Which means if this is 3 dimension, so this is x axis, y axis and z axis. Now I will draw one line like this and one line we have like this. I will take one point on the line x1 comma y1 comma z1. So this is the fixed point and I will take this as A, and I will take one more point x comma y comma z. So this is the moving point, so which means I will take this as P, and here fixed point, one point on the line is given and a vector which is parallel to this line. So this vector B vector, I will take this as B vector, so this will be given. Now if these two things are given, how to write the equation of that line we can see now. So we have two forms in 3D. So one is vector form and the another one is Cartesian form. So we will see the both the things. So here in this vector form, this is the origin 0 comma 0 comma 0. Now I will draw one vector where the initial point is origin. If initial point is origin, we call that vector as position vector. So here O2A and O2P. So it forms one triangle. So AP vector, OA vector plus AP vector will be same as OP vector. So from here AP vector will be equal to OP vector minus OA vector. So whenever we have any vector, let's say PQ vector, terminal minus initial, OQ minus OP vector I have to write. If I have RS vector, then terminal minus initial, OS vector minus OR vector we have to write. If we have SR vector, then it is OR vector minus OS vector. So terminal minus initial we have to write. And we got AP vector equal to OP minus OA. So OP vector is what? I will take this is some R vector. R vector is what? Xi cap plus Yj cap plus Zk cap. Suppose if we have any one point, let's say 2 comma 3 comma 4. So now from the origin, if you are making one vector like this, it will be 2i cap plus just the coordinates is the directional ratios for this, 2i cap plus 3j cap plus 4k cap. So like this only we have to write, which means R vector is equal to x comma y comma z is the point. So it will be xi cap plus yj cap plus zk cap, and OA vector will be equal to x1 i cap plus y1 j cap plus z1 k cap. So from here this vector I will take as A vector, and AP vector equal to OP means OP is R vector minus OA is A vector. Now if we see this A vector, this AP vector, this AP vector and this B vector are parallel. Since the line itself is parallel, means on the line only AP vector is there, which means AP vector and B vector are parallel. AP vector and B vector are collinear vectors. If it is collinear vector, then directional ratios will be proportional, which means AP vector can be written as some lambda times B vector. So what I will do here is I will just substitute this here. So it will be lambda times B vector equal to R vector minus A vector, and from here we got R vector equal to A vector plus lambda B vector. So this we call as vector form of the line, vector form. This is the vector equation. Now we'll see the Cartesian form. Cartesian form. So in this Cartesian form, what is R vector? It is xi cap plus yj cap plus zk cap equal to A vector is x1 I cap plus y1 j cap plus z1 k cap plus lambda times. I will take the directional ratios of B vector as some A I cap plus B j cap plus C k cap. So which means it will be equal to A I cap plus B j cap plus C k cap here. And from here, if two vectors are equal, then I can equate the components. So here x we have x equal to, and here x1 plus here also I we have, so lambda I. So x equal to x1 plus lambda I, y equal to y1 plus lambda b, and z is equal to z1 plus lambda c. From here we got x minus x1 equal to lambda a, which means if this a comes here, x minus x1 by a equal to lambda. So y minus y1 by y minus y1 equal to lambda b. If this b comes here, it will be divided by b. So z minus z1 by c equal to lambda. All are equal to lambda means the ratios are equal. So I can write x minus x1 by a equal to y minus y1 by b equal to z minus z1 by c. So this is the this is the Cartesian form. Cartesian form. The next thing here. So in 2D, the another form we have is 2-point form. So what is 2-point form? 2-point form is nothing but 2 point on the line will be given. 2 point on the line will be given. Here slope is not given. If slope is not given here, I can find the slope x1 comma y1 here, and this is x2 comma y2 here, and this general point I will take x comma y. So x comma y is the moving point. So here m slope is not given. If it is not given also, we can find the slope. So it will be y2 minus y1 by x2 minus x1. Same thing I will do here. So this is for x comma y, this is the moving point. So y minus y1 by x minus x1 equal to, this is the same slope we have, so which is y2 minus y1 by x2 minus x1. So from here we got 2-point form equation. So y minus y1 by y2 minus y1 equal to x minus x1 by x2 minus x1. So here also the same thing in 3D, 2 points on the line will be given. Now this is for 3D now. 3D. Two points on the line will be given. 2 points on the line will be given, which means the parallel vector is not given here. Here in the first form, point slope form, 1 point on the line will be given and slope of the line will be given. So here in 3D, 1 point on the line will be given, and instead of slope, here we have parallel vector to the line, which means here the parallel vector is not given here, because instead of slope we have one parallel vector to the line. 2 points on the line will be given. If parallel vector is not given, we can find vector. Since here slope is not given, here we can find the slope. Here parallel vector will not be given here. We can find that parallel vector. So we can see that now. So x, y and z axis. So 2 point on the line is given. So which means I can take this point as x1 comma y1 comma z1 and take this as A, and this point I will take as B, so it is x2 comma y2 comma z2, and one general point I will take which we call as moving point. So P, it is x comma y comma z, so this is the moving point. So if it is moving point, from this I am taking the position vectors. So this I will take as A vector, and this I will take as B vector, and this I will take as R vector. Now the same thing with the moving point, I have to find this vector AP vector. Same thing we have done in the previous one. So terminal minus initial, so OP vector minus OA vector, and AP vector will be equal to OP is R vector and this OA is A vector. So we have this one. Now here we have written AP vector as some lambda times B vector, that B vector is parallel to the line, and here we are not having any parallel vector. So what I can do here is, if we just compare these, which is AP vector and AB vector, AP vector and AB vector, so just the magnitude is changing, which means I can able to write this AP vector as some lambda times AB vector. So now AB vector is nothing but OB vector minus OA vector. So OB vector will be equal to B vector and OA vector will be equal to, this is A here, so B vector minus A vector. So in place of this AP vector I can just substitute this one, some lambda times B vector minus A vector. So if I substitute this here, it will be lambda times B vector minus A vector equal to R vector minus A vector will be there. From here I got R vector equal to, if this minus A comes here, it is plus A, so A vector plus some lambda times B vector minus A vector. So this is the Cartesian form if 2 points are given. This is the, sorry, vector form, not the Cartesian form. So vector form if 2 points are given, if 2 points are given. So this B vector is the position vector of the point on the line, and A vector is also the position vector of the point on the line. So now we will see the Cartesian form. Cartesian form. So just I will write this, the previous one, if R vector is equal to A vector plus some lambda times B vector. So we have written, this is the vector form, and the Cartesian form for this, it was x minus x1 by A equal to y minus y1 by B equal to z minus z1 by C. Okay, so this x1 y1 z1, x1 comma y1 comma z1 is the point on the line, and this A, B, C are the directional ratios of the parallel vector. Parallel vector. Now the same thing here, we have R vector equal to A vector plus some lambda times B vector minus A vector. Now if we just compare this, here A vector is there, which means the point on the line, the numerator will not change, x minus x1, y minus y1, z minus z1. After lambda times B vector, the directional ratios of B vector we are writing here. Here lambda times B vector minus A vector is there, which means in the denominator we have to write the directional ratios of B vector minus A vector. So which is x2 minus x1, y2 minus y1, z2 minus z1. Here B vector is there, in the denominator we have written the directional ratios of B vector. Here in the denominator, we have to write directional ratios of B vector minus A vector. So what is B vector minus A vector? x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. So from here we got the Cartesian form. This is the Cartesian form if 2 points are given. So now if in question they have given one Cartesian form like this, and we have to find the point on the line and the parallel vector to the line. Here if we see coefficient of x minus x1, which is in the numerator, the coefficient of x should be 1. No need to take the denominator part. Here it should be 1. Here also the coefficient of y, here it should be 1 in the numerator, and the coefficient of z should be 1. Then only we can take the values of x1, y1, z1, a, b, c. 6 values we had to take. So we can see this now. Suppose if equation it is given in the question, suppose 2x plus 3 divided by 5 equal to minus y plus 12 divided by 3 equal to z 2z plus 7 divided by 6. If it is given like this, we have to, this is line equation, we have to find the point on the line. Let's say we have to find this point on the line. So and the parallel vector to the line. So parallel vector to the line, I will take this vector b vector, and here the directional ratios I cap plus directional ratios j cap plus directional ratios k cap. So I have to fill these 6 blank spaces. So if I write this as b vector as 5 I cap plus 3 j cap plus 6 k cap, and here it is minus 3, minus 12, 7, it is wrong. So before taking the values of x1, y1, z1, a, b, c, first we had to make the coefficient of x only in the numerator, it should be 1. Coefficient of y, which is in the numerator, it should be 1, and coefficient of z for numerator part alone, it should be 1. So what we have to do here is, we have to take whatever be the coefficient of x, you have to take that as common. So it will be x plus 3 by 2 divided by 5 is there, and here it is minus 1 we have, so minus 1 we have to take common, so y minus 12 divided by 3 equal to 2 we have to take common, so z plus 7 by 2 divided by 6. So which means this 2, if it comes here, it will be in the denominator. I have to divide by 2 in the numerator as well as in the denominator. So it will be x plus 3 by 2 divided by 5 by 2 equal to y minus 12 divided by minus 3 equal to z plus 7 by 2. This I can cancel here itself. So 2 1s are 2, 3s are 6, so divided by 3. So now only I can write this one. The parallel vector will be equal to, parallel vector to the line, it will be equal to 5 by 2, here 5 by 2 will come, and here it will be minus 3, and here it will be 3. Sorry, the point on the line will be 3 by 2, the negative of this x minus x1, the negative of this, so minus 3 by 2, and the negative of this minus 12 means the negative of this is will be 12, just we have to change the sign, so this will be minus 7 by 2, and here the parallel vector will be 5 by 2 minus 3, and here it will be just 3 here. So like this only we have to find. So before taking the point on the line and the directional ratios of the parallel vector, we have to make the coefficient of x, y, z as 1. So then only we can take the values of x1, y1, z1 and a, b, c. So we have two forms. One is 1 point will be given, 1 point will be given, and the parallel vector will be given. For that the vector form was r vector equal to a vector plus lambda b vector, and Cartesian form is x minus x1 by a comma equal to y minus y1 by b equal to z minus z1 by c. And in 3D, if 2 points are given, then it is r vector equal to a vector plus some lambda times, lambda is some constant, so into b vector minus a vector. So after this, the Cartesian form is x minus x1 by x2 minus x1 equal to y minus y1 by y2 minus y1 equal to z minus z1 by z2 minus z1. So this is the example we have to find the point on the line and the parallel vector, because it is very important to find the shortest distance. So we have to take the point on the line and the parallel vector. So we have to know this concept. So this is from vector form we are taking. What if we have to take from the this is from the Cartesian form we are taking. What if we have to take from the vector form? From vector form, suppose if some equation is some line equation is given as I cap plus 2s I cap plus j cap plus s k cap plus 7 k cap plus 2s j cap. Suppose if it is like this, so we have to just separate the s term separately. S times s is one scalar here, s is some scalar, it is like lambda. Okay, so I have to write separately, s term separately I have to write, and without s I have to write separately. So I cap plus j cap, this is without s, this is without s, and this is also without s, plus 7k cap. Now I have to take s common. After taking s common, so what we have, 2i cap, and here it is 2j cap plus k cap. So after writing this, the point on the line will be equal to just this one. So this is the position vector of the point on the line. So which means the point on the line will be 1, 1, 7, and the parallel vector will be equal to 2i cap plus 2j cap plus k cap. So like this only we have to find the point on the line and the parallel vector if the line equation in the vector form is given like this. So it is very important to find the shortest distance. So next concept we are going to see is how to find the shortest distance between two lines. So now we will see shortest distance of two lines, between two lines, shortest distance. So in line we have 4 different cases first. 4 different cases we have. So first case, it will be intersecting, and the second case it will be parallel like this, parallel, and the third case coincident lines, this coincident lines, and the fourth case skew lines. So this is line 1 and this is line 2 here. So all these first three we call this as coplanar lines, coplanar lines. Suppose if two lines intersects, which means here it intersects, which means the shortest distance will be equal to 0. This is line 1 and this is line 2, and this is parallel lines, parallel lines. So here we can find the shortest distance, which we will see now. Next, this is coincident line, coincident line. So all these 3 forms you have learned in your 10th standard. So this is intersecting lines, this is one is intersecting lines, shortest distance of intersecting lines is 0. Coincident lines, so here also the shortest distance will be equal to 0. So now this line is non-intersecting and non-parallel. See here, if it is parallel lines, it will be non-intersecting, this we know. So non-intersecting and parallel means this one, and non-intersecting and non-parallel means we call these type of lines as skew lines, skew lines. So we have to imagine this in 3D, so we should not imagine this in 2D. So this is non-coplanar lines, it is not in the same plane, it is in the different plane. This is non-coplanar lines. So we will see that line now. Suppose 2 lines we have, one is in red color, one is in black, 2 of them are in black. So if we see from here, it looks like intersecting. So this is non-parallel, it is not parallel. So now if I just rotate this here, it is not intersecting. So this is that line we have. So this is skew lines. So they go like this, they never intersect, as well as they are not parallel. So we call these type of line as skew lines. Suppose if we see from here, it looks like intersecting, so it is not 2D, we have to imagine this in 3D. Suppose if I just rotate like this, so it will be non-intersecting as well as non-parallel. So it is, we call these type of lines as skew lines. Suppose what is the shortest distance between these 2 skew lines is, we have to take perpendicular distance. Shortest distance means it is perpendicular distance, which should be perpendicular to this line as well as this line. So this will be the shortest distance. It should be one line, this should be perpendicular to this line 1 as well as this line 2. So though these type of lines we have, so in this we have to take the perpendicular distance, this will be the shortest distance. It should be perpendicular to line 1 as well as it should be perpendicular to line 2. So this length of this is shortest distance. Okay, so just we will see the formulas for all those things now. Okay, so first we will see for skew lines. We have to find shortest distance. Shortest distance means it is perpendicular distance. So we have one line like this is line 1, and the another line like this is line 2. See here, if line 1 equation is given, either they can give in vector form or they can give in Cartesian form. In both of this, they will give one point on the line. So we know one point on the line, so which means we know x1 comma y1 comma z1, and the parallel vector to this line, I will take this as b1 vector, and this point is in a1, and for this line 2, one point on this line 2 will be given a2, and parallel to this line 2 one vector will be given, let's say that vector is b2 vector. Now we have to find one vector which is perpendicular to both line 1 as well as line 2. We know that in cross product a cross b vector, suppose if we have, so this the formula will be magnitude of a vector into magnitude of b vector into sine theta into n cap. So this n cap, this is the direction we have. This direction is nothing but it will be direction is perpendicular to both a vector and b vector. If I take some cross product, some vector, if I get, let's take this vector as c vector. So this c vector will be perpendicular to both a vector as well as b vector. So if it is perpendicular, then I can say a dot c vector will be equal to 0 and b dot c vector will be equal to 0. So here also we need a one vector which is perpendicular to both line 1 and line 2. So which is same as saying it should be perpendicular to b1 vector as well as b2 vector. So if I need one vector which is perpendicular to both these vectors, is I have to take cross product. If I take cross product, this vector b1 cross b2, it will be perpendicular to both b1 vector as well as b2 vector. So this vector I can take b1 cross b2 vector. Now what I have to do here is I have to find the distance of this. So this is just the direction. So it can stop here also, or it can till be here also. So this is b1 cross b2, we have this vector. What I have to do here is I have to project this. If I join these 2 points, so this will be a2 minus a1 vector. So what I have to do here is I have to project this vector on this b1 cross b2. So projection of shortest distance is nothing but just so from here, shortest distance of skew lines, just we have to remember this statement, projection of a2 minus a1 on b1 cross b2. So just this statement is enough. Just we have to remember this. See here, projection of this vector a2 minus a1, I have to project on this b1 cross b2 to get the magnitude of this shortest distance from here to here. Okay, so which means projection of a vector on b vector means this will come in vector, projection of a vector on b vector. So whatever here we have to take the dot product of this. After on whatever we have, this b vector we have, so here I have to take the magnitude of this. So this is the projection of a vector on b vector. And here for this shortest distance for skew lines, so it will be equal to projection of a2 minus a1 on b1 cross b2, which means I have to take the dot product of this. After this I have to divide by the magnitude of whatever vector on we are projecting, which is b1 cross b2. Since distance cannot be negative, I have to put modulus. This is modulus. So this is the formula for shortest distance of two skew lines we have. Okay, shortest distance between two skew lines. So projection, this statement we have to just remember. So projection of A2 minus A1 on B1 cross B2. Next we will see what is the shortest distance if we have parallel lines. This is for parallel lines. So if we have parallel lines, let's say line 1, this one, and this say is line 2. So if line 1 is given, one point on this line 1 will be given, let's take that as A1, and one point on this line 2 will be given A2. So here one vector which is parallel B vector. See here, if it is since line 1 is parallel to line 2, B1 vector will be parallel to line 1, line 1 is parallel to line 2, which means the parallel vector, this B vector, is common for both line 1 as well as line 2. Now we have to find the shortest distance. So to find the shortest distance, what we have to do here is we have to just take one point. Either A1 I can fix, or I can fix A2. So from this point I have to draw one perpendicular line. So from this I will just join this one. So this is A2 minus A1 vector, this direction, and the magnitude of this will be magnitude of A2 minus A1. Okay. Now what we have to find, the shortest distance is this one. This is my shortest distance we have. This is the shortest distance. So now it makes some angle theta. See here, theta is the angle between A2 minus A1 vector and line 2. So this is theta we have. Okay. So which means what I can go here is I have to find for this theta, hypotenuse is given, which is magnitude of A2 minus A1. I have to find opposite. So opposite and hypotenuse comes in sin theta. So I have to go with sin theta. So sin theta equal to opposite, which is the shortest distance, divided by hypotenuse, which is magnitude of A2 minus A1. Now what I can do here is the formula for shortest distance now we got here is magnitude of A2 minus A1 into sin theta. So this is the shortest distance we have. Next, so just I will cut this. Yes. So now shortest distance we have like this one. Now this sin theta comes in dot product or cross product that we have to see now. So after seeing this, sin theta comes in cross product. So now I have to find the cross product of two vectors so that the angle will be the same theta. Now see here, theta, angle between A2 minus A1 and B vector. See here, this B vector is parallel to line 2, which means this B vector with the free vector concept, I can just move here the same angle, it is again theta only. So it is again same theta we have in B vector if I move here, since it is parallel. So what I can do here is same theta, the angle is same theta. Angle between B vector, angle between A2 minus A1 and B vector will be same theta. Okay, so which means what I can do here is I can just take cross product with A2 minus A1 cross B vector. So now I have to apply the formula, so it will be equal to magnitude of A2 minus A1, because cross product formula is magnitude of A vector into magnitude of B vector into sin theta into n cap. So this is the formula. This formula I have to use. In place of A we have A2 minus A1, in place of B we have B only. So into magnitude of B vector into sin theta into n cap. But this is vector, we have to find the magnitude, which means I have to take modulus, magnitude on both sides. So magnitude of n cap is what? Since n cap is a unit vector which is perpendicular to both A2 minus A1 and B vector, so this magnitude of n cap will be equal to 1. So now what I can do here is, now the shortest distance is nothing but A2 minus A1 into sin theta. So this A2 minus A1 into sine theta, this we have. So this is nothing but the shortest distance. So shortest distance will be equal to magnitude of a2 minus a1 cross b vector. This b vector will come here, so divided by b vector. So this is the magnitude we have. Okay, suppose in this q lines itself, suppose if two lines are intersecting, which means what is the formula we have? Projection of, just we have to remember this statement, a2 minus a1 on b1 cross b2. So which means here the formula for shortest distance for skew lines is what? a2 minus a1 dot b1 cross b2 divided by magnitude of b1 cross b2. So this is the formula we have. Now here, if two lines intersects, if two lines intersects, then shortest distance will be equal to 0. This we know, which means the condition will be a2 minus a1 dot b1 cross b2, the numerator will be equal to 0 itself, provided the b1 cross b2 is not equal to 0 vector. Okay, because in denominator we have magnitude of b1 cross b2. So this statement will be there, a2 minus a1 dot b1 cross b2, if it is equal to 0, then two lines intersects. If two lines intersects, they will ask to find the point of intersection also. So how to find the point of intersection? What we have to do here is, first line x minus x1 by a equal to y minus y1 by b equal to z minus z1 by c. Suppose if they have given like this, it will be equal to some lambda. And now another line they will give, so some x minus some x2 by a1 b1 c1. So a2 equal to y minus y2 by b2 equal to z minus z2 by c2 equal to some mu, because it will be some proportional scalar, so I will take that as mu. So now what I have to do here is just this I will just equate. So x equal to a1 lambda plus x1, and from here y will be equal to b1 lambda plus y1, and from here z will be equal to c1 lambda plus z1. Okay, but no need to take this one, just two things is enough. So here, from here x will be equal to a2 mu plus x2, and y will be equal to b2 mu plus y2. Since we have to find the point of intersection, where here if you have some x comma y comma z, same x comma y comma z should be here, which means one point we have to find. So we have to substitute, we have to solve this, which means a1 lambda plus x1 should be equal to a2 mu plus x2, and from here b1 lambda plus y1 equal to b2 mu plus y2. Just we are solving, in place of a, just I am equating. So from here I will get one linear equation in this form. So a1 lambda minus a2 mu equal to x2 minus x1. This is one linear equation. Lambda and mu is the variable we have, a1 we know and a2 we know. Okay, so from here b1 lambda minus b2 mu equal to y2 minus y1. So these two types of equations we have, linear equation. After solving we will get the value of lambda and mu. After getting the value of lambda, it's enough, just we can find the x coordinate of that will be the point of intersection. The last concept in this 3D is foot of the perpendicular. Foot of the perpendicular and image of the point. So how to find the foot of the perpendicular, and what is foot of the perpendicular? Suppose if we have any point, let's say u comma v comma w. Now any line equation we have, if they have given the line equation, one point on the line we know and the parallel vector we know, they have given in this form x minus x1 by a equal to, I will take with example itself, let's take 1 comma 2 comma 3. This is one point we have to find the foot of the perpendicular. Foot of the perpendicular is nothing but the coordinate on the line. From this point I have to draw one perpendicular line. Wherever it intersects, we have to take the coordinate of this. The coordinate of this is foot of the perpendicular. Coordinate of this point is foot of the perpendicular. Suppose if line equation is given in this form, x minus 2 by 3 equal to y minus 1 by 2 equal to z by 3 equal to some lambda will be there constant because it is same ratio. Now x coordinate of this, any point on this, see here, any point on this line, this is line 1, on this line will be of the form x equal to 3 lambda plus 2, y equal to 2 lambda plus 1, z is equal to 3 lambda. Any point on this line will be of this form. If you keep on changing, lambda is the parameter. So if we keep on changing the values of lambda, we will get one point. So here this point will be some value of lambda will be there, here some value of lambda, here some value of lambda. All the points we will get if we keep on changing the values of lambda, which means here also some lambda will be there. This coordinate will be of this form 3 lambda plus 2 comma 2 lambda plus 1 comma 3 lambda will be of this form. And if line is given, one point on the line is given, which means the point is given as 2 comma 1 comma 0, and the parallel vector for this line is what? 3i cap plus 2j cap plus 3k cap. What I can do here is I can find the directional ratios of this line. Directional ratios of this line. If 2 points are given, we know how to find the directional ratios. Just we had to subtract the coordinates x2 minus x1, y2 minus y1 and z2 minus z1. And this vector is perpendicular, which means the dot product will be 0. From there we will get the value of the lambda. So we will do that now. So first I will find the direction. Let's say this is A and B. So directional ratios of AB. So either we can go with x2 minus x1 or x1 minus x2. So we will go with x2 minus x1. So 3 lambda plus 2 minus 1. 3 lambda plus 2 minus 1. Next 2 lambda plus 1, and here it is minus 2, and the next 3 lambda minus 3. So now we have to just solve this. This we have to simplify. So 3 lambda 2 minus 1 is what? 1. 2 lambda 1 minus 2 is minus 1. 3 lambda minus 3, we have to keep that as it is. So these are the directional ratios we have. Let's say A1, A2, A3. So this is perpendicular to 3i cap plus 2j cap plus 3k cap, which means the dot product will be equal to 0. So what I can do here is 3 lambda plus 1 times the component of I, which is into 3, plus 2 lambda minus 1 into 2 plus 3 lambda minus 3 into 3. So this will be equal to 0. From here we will get the value of lambda. So after solving this, what we will get here is 3 into 3, so 9 lambda. 9 lambda plus 3 plus 2 2s are 4, so 4 lambda minus 2 plus 3 3s are 9, so 9 lambda minus 9 equal to 0 we got. Which means from here 9 plus 9, 18, 18 plus 4. So 18 plus 4 is what? 22. So 22 lambda, 3 minus 2 is 1, so 1 minus 9 is minus 10, so minus 10 equal to 0. So from here 2 lambda equal to 10, 3 minus 2 is 1, so 1 minus 9 is minus 8, so here minus 8 will come, so which means 22 lambda equal to 8, so lambda will be equal to 8 by 22. So after this we have to just simplify this. I can cancel with 2 tables, so 2 4s are 8, 2 11s are, so lambda will be equal to 4 by 11. So after finding the value of lambda, I have to just substitute here. So 3 into 4 by 11, foot of the perpendicular will be this. I will just copy. So this is the foot of the perpendicular. For this, value of lambda is 4 by 11. So just I have to substitute that. 3 into 4 by 11 plus 2 comma 2 into 4 by 11 plus 1 comma 3 into 4 by 11. So this we have to just simplify. So it will be 3 4s are 12. So 12 by 11 plus 2 comma 8 by 11 plus 1 comma 12 by 11. So from here 12 plus 22 by 11, 8 plus 11 by 11 equal to 12 by 11. So from here we will get 22 plus 12 is 34, 34 by 11, 8 plus 11 is 19, so 19 by 11 comma 12 by 11. So this will be the foot of the perpendicular. And they will ask image also. Image also they can ask. To find the image, copy. They will ask image of a point. Image of a point. Same thing for image of a point, whatever we had done we have to do. So after that, image is nothing but whatever distance here we have, with the same distance here also perpendicularly, here one coordinate. This coordinate we call as image of a point. Image of A. Image of point A. Which means this B is, let's say this is C. So B is the midpoint of AC. B is the midpoint of AC. Which means if I take this as some alpha, beta, gamma, what I can do here is I can write 1 plus alpha by 2 equal to 3 lambda plus 2, which we got foot of the perpendicular 34 by 11. From here we will get the value of lambda, and the next 2 plus beta by 2 equal to coordinate of y of the foot of the perpendicular, so it will be 19 by 11. Next 3 plus gamma by 2 equal to 12 by 11. So after solving this, we will get the value of alpha, beta, gamma, so that will be the image of point A. So from this we have completed all the concepts from 3D. So in the next section we can practice the questions which is given in the revisions. Practice questions.